Start webinar கொடுத்தா போதும்ல. webinar இல்ல. பாஸ் பண்ண ரெக்கார்ட் பண்ண தேவையில்லை. பாஸ் பண்ணி
Hello. Are you getting my voice?
We are able to hear you well. Yeah, we are able to hear you well, Amit. You started traveling? Is it with a PCR?
Without RT-PCR, not required in this area. Actually, I got approval from Food Safety and Authority of India, so we are working some project for them. So that is the reason I'm here actually.
Oh. But I think to enter Maharashtra, you require PCR.
In Maharashtra, but in Gujarat, it is not required. If you are coming from Maharashtra to Gujarat.
Hi, good afternoon, HK.
Good afternoon, man. Good afternoon, everyone. Hi, Alexi, how are you?
Super fine, and you?
Yeah, doing good. Great. Hi, sir. How are you, sir?
All good, yeah.
Amit, you are able to share your screen. Can you just quickly check before we start? I think we have another 3 minutes.
1 minute. Actually, I'm just sending my PPTs to you. One minute, I'm sharing, so I will.
Are you able to share your screen?
Is it visible to you?
Yeah, it's visible.
This is my screen.
It's visible. Yeah, can you put it on slideshow? Yeah, now it's on slideshow. Yeah, good.
So in the meantime, I'm sending these slides to you also.
Yeah, please send it because somehow in between I'm losing connection. So I think I'll have to connect over mobile and put you on the speaker. Connection is weak. Alexi, your connection is okay, na? I think we can hear you loud and clear.
Yes, it seems okay today.
And what about me?
Yeah, it's okay too for me.
Your signal is going off in between coming. So Amit, Velumurugan, can you just see if we can put him on speaker? Just do a try. We call him on phone and put him on the speaker.
Yes, we have connection issue here.
No, Amit Bahadur.
Hello. I think I'm clear to everyone now.
Yeah, you are clear. You are clear.
Now you are clear. Hello. Yes, sir. Okay. Hello. The network is unstable.
Hello.
Hello.
Yeah.
Madam, you
Yeah.
can
we start?
I think the network is outside.
Okay. Velu Murugan, are you? Network was not working. Let me start.
I think let us start.
Am I audible?
Yes. You are audible.
Good morning, good afternoon, and good evening to all the panel members and the participants. We have people logged in from different locations of the globe. LXC is in Europe, and we have people in different parts of Southeast Asia. So hope you can see the screen and I'm audible to all of you. So welcome to all the participants to the Flame Retardancy Learning Series 8. Environmental Impact, Reach RoHS Compliances and Halogen-Free FR Products. This is jointly brought to you by Formulated Polymers Limited and Eurostar, now Ascend Performance Materials. So it's heartening to see such a positive response. And we see that people from our earlier webinars have also joined us today. So we are happy to see a lot of with relation to the flame retardant products. So today we are looking at environmental, the declarations, and even section claims. We see a lot of ISO 14,000 2016, and we see organizations looking at sustainable the ability of future generations to meet their own needs. So what we are looking at today is, and what we want to discuss is sustainable development, and this is about integrating the goals of a high quality life, health and prosperity, and maintaining the Earth's capacity to support life in all its diversity. So the social, economic, environmental goals are interdependent and mutually reinforcing. And as we see that both Formulated Polymers Limited and Eurostar Ascent Performance Materials are highly focused on maintaining these norms and working towards these compliances at all levels, whether it's an environmental compliance, or it's a technology compliance, or it's basically approvals in terms of long-term sustainability. So as explained earlier to you, this is for practicing professionals. It's a knowledge sharing platform where we share the knowledge on electrical, electronics, automotive, electric vehicles, appliances, and emerging markets of automation, artificial intelligence, and so and join us and do the participations. Presently in all the webinars, we have had a lot of positive response, and we look forward to having many more people. I'm Rashmi Bharadwaj, Vice President Development with Formulated Polymers Limited. The webinar would be for 45 minutes, and I'm the moderator for this session. We will have at the end of the session 10 minutes of question answers. So we would request all the joinees to post their questions in the Q&A box and not in the chat box. Then just going back quickly in terms of, because we'd all like to hear Amit and Alexei talking about environmental impact and how we are complying and working towards that. So just a quick that we have already done series 6 over here, where we have gone right from history to mechanisms to testing, characteristics, standards, UL, VD, processing, and we've also covered the design perspective. So today's session is the 8th session, which is on the environmental impact. There are around 4 more sessions which we have planned as of now, but then we can take it more in case there is further interest. So in the next session, we'll be covering up cross-linked polymer systems. Just a quick recap so that all those who have attended and those who have not attended are on the same page. We have the YouTube link given to you where you can join, click on YouTube and see the earlier sessions whenever you want to. It's based upon your interest. So if I go back to our session, then what we covered earlier was basically retardant plastic took place, and what ISO norms which are being followed by all of us, especially in terms of the classification. We covered the flame retardant mechanism in Learning Series 2. In Learning Series 3, we had Mr. Krishnamurthy and Alexei giving 2 sessions, 3 and 4, with respect to the UL 94 testing, the GLOWAR testing, because sometimes we consider them as we have to understand the total mechanism and the reason why these tests are done. So we had this entire session. We covered the LOI, the solvent arc ignitions. So it was Mr. Krishnamurthy, CDs 5, where we covered standards, like how do you read a UL standard? We are all aware of UL standards, but sometimes we don't have a clarity in terms of what we have to read in those standards. So we had a session with Mr. Chaudhary on VDE, who's head India operations for VDE testing and certification. Then we had another session in terms of processing, that's series 6, where Mr. Satish Kumar Principal Architect Schneider and Alexei gave us their insights in terms how to process FR compounds, what is important when we are processing these compounds, and how do we capture the part quality and the consistency for these materials. Then the last session, which was earlier this year, was on design perspective in flame retardant components, where Mr. Prashant Viragi, he was earlier with L&T, now with Schneider. He gave an overview of switchgear applications. And his presentation, Pradeep Chaudhary discussed in detail regarding the product design optimization with FR compounds. That's like disruptive innovation in product design, manufacturing, engineering, and simulation, where he covered a number of applications, right from simple automotive applications, the general purpose ones, to the specialized applications and the requirements in terms of design, where aesthetics is important, as well as technical functionality is also important. Now coming to this session, we have our speakers on the environmental impact. Mr. Amit Bahadur Singh will be presenting from Eurostar Engineering Plastics, now Ascent Performance Materials. Some of the industry professionals have agreed, already some have presented, and we would request more industry professionals. Performance Materials and Formulated Polymers Limited Asia specialize in compounds of engineering polymers. Most of the examples which we will be discussing will be based upon polyamides, polyamide 6, 6,6, ABS, polypropylene. So just to cover basically, STARFLAM is manufactured by Formulated Polymers Limited and Ascent Performance Materials, and are available in both reinforced and unreinforced polyamide grades with high impact and tight tolerances, flammability values of UL94V2 to V0 down to 0.4 mm thickness, 5VA, 5VB classification, as well as UL746 polymers like polypropylene, ABS, PC, PBT, etc. So we have like around 120 UL yellow cards. Comparative index values go up above 600 volts. RTI above 120 degrees centigrade up to 150 degrees centigrade. Various compliances which we are discussing today in detail. Excellent ductility and low warpage, easily laser marketable. So just to give a brief about our speakers, Mr. Amit Bahadur Singh, he is limited Pune. I've shared his mobile number and email ID just in case someone wants to get in direct touch with him. You can communicate either by mail. Amit Bahadur Singh, for 12 years experience, he has a versatile experience and has worked with Hook Tamaki and Positive Packaging and SGS India Private Limited, presently with TUV. He is a MSc Physics Masters in Marketing Management and has a rich experience in REACH RoHS regulatory compliances and product risk management. He is a CQI IRCA approved ISO 9001 quality management system certified lead auditor. So we look forward to hearing from him regarding what is the environmental impact, what exactly REACH RoHS, why are these compliances so important, and why is it gaining even more and more importance as we move forward. So we look forward to you, Mr. Singh. The other speaker is Mr. Alexei Chopin, Technology Head, Eurostar Engineering Plastics. Now Eurostar has been acquired by Ascent Performance Materials. So Alexei has earned his master's in engineering in plastic engineering from iTech Lyon. He has over 25 plus years of experience in formulation, compounding, application development. I think he's him, or I just call him up and get aware of polymers and what we have to do, how it is to be done. So we look forward to hearing him. He's a co-applicant of many patents in FR engineering plastic compounds, including the cross-linked polyamides. He's a subject specialist in low voltage, medium voltage, control equipments and polymer compounds, especially in the FR design and section. So he will be handling the halogen-free FR products and the environmental impact. Now, I'd like to hand over to Mr. Amit Bahadur Singh. I think quickly I'll share, he has shared a video of his. I'll just quickly put it, which talks about TUV capabilities. I presume all of you are aware, but then I thought it was important to just quickly share for all those who are not aware or have a limited knowledge about TUV. So Amit, I'm just stop sharing. You can share your presentation.
Okay. Thank you, Mr. Smith. So hello, good afternoon. So as Ms. Rasmi we will discuss about this REACH and RoHS requirement and environmental impact. So this will be the agenda for RoHS and its objective, and what is the important definition and what is concept. So basically, RoHS stands for restrictions of hazardous substances, and it basically in the earlier time in European Union there was a huge amount of electrical electronic waste generated, and European Union found that there are many hazardous substances are also a part of these electrical electronic wastes. So they decided to restrict these actually hazardous substances. So they come up with two directives. One is RoHS directive, and second one is WEEE directive to promote collection and recycling of such electrical electronic equipment, so that it can be recycled and the environmental impact will be minimum. So this is the definition given in RoHS 2. So any equipment which is dependent on electric current and electromagnetic field in order to work properly, and equipment which are to generate, transfer or measure such currents are also considered as a electrical rating. That EEE will be considered as a if voltage rating is less than 1000 ppm and DC voltage is less than 1500 volt. So this is actually journey from initial directive that is 2022 to 95 EC, that is RoHS 1 to RoHS 2 and its amendment. So this RoHS 1 came into effect on July 1, 2006, and RoHS 2 came into effect from second amendment in Annexure 2 to add 4 more elements to the hazardous substance list. So it actually come into force on 22nd July 2019, and it will be fully effective from 22nd July of 2021. So basically, we are discussing about this RoHS 1. So RoHS 1 overview means there was no formal certification, declaration, or labeling system for testing the compliance. And 2 categories were exempted, that is medical device and monitoring control instruments. And producers or manufacturers of EEE has to show the evidence once it is asked by the authorities. So there was no actually formal certification like C or testing RoHS compliant logo on product. It was a not requirement of RoHS 1. In RoHS 1, 6 elements were listed, which are mentioned here: lead, mercury, cadmium, chromium 6, PBB, and PBD. So basically known as flame retardants. So categories covered in this scope, these categories actually taken from the WEEE directive. So there was 10 categories were listed. So they have taken, and 9 were not actually in the scope of RoHS 1. So RoHS 2 basically it is a recast directive to make simple, effective, and enforceable directive. So earlier there was a not a clear definition for EEE, and there was not a clear definition for obligations of the manufacturer. So this directive come as a recast directive, RoHS 2. So it has come for aligning and harmonizing with other EU legislation, and it covers all EEE, basically whatever the actually not covered from categories 1 to 10. So they come up with new category that is known as category 11. So all things were covered under that category. And list of substances does not change in RoHS 2 as well. So 6 substances were listed in RoHS 1. So 6 substances were listed in RoHS 2. So their maximum concentration was actually calculated as per homogeneous material basis. So these are the categories basically covered in the scope of RoHS 2. So all the categories which were listed in WEEE, waste of electrical and electronic equipments, and one more category is added in this scope, that is category 11. So other EEE not covered by any of the categories above. So all the things which are actually manufactured by for the electrical and electronic industry, those are if not covered until 10 category, then it will actually come into the category of 11. So nothing is left. And actually, as I told you earlier, so this came as a recast directive, and the purpose was this directive to align these requirements with other regulations also. So they have given a special condition that RoHS shall apply without prejudice to requirements of union legislation on safety and health, and REACH, and requirement of specific union waste management legislation. So RoHS will also be applicable, and other these regulations will also be applicable side by side, like REACH regulation. So what is out of scope? So anything which is for national security and military equipment, that is actually out of scope. Equipment sent to space. If any equipment will be a part of exempted category, so that equipment will also be exempted, like the large scale stationary industrial tools, non-road mobile machinery, active implantable medical devices. So these are the category actually out of scope from the RoHS. Otherwise RoHS is applicable. So the highlight of RoHS 2, so as we discussed, there was no addition of a category 8 and 9 in RoHS 1. So this RoHS 2 category added these categories. And category 11 they introduced that which impacts wire, cables and connectors. Application exempted, so they have actually exempted category for category 8 and 9, and other category also, like medical devices and monitoring devices. They have separate exemptions list, which is listed in Annexure 4. So Annexure 5 format for granting, renewing, revoking exemptions are given. So anybody want to have apply for the grant of exemptions or want to renew the exemptions or want to revoke the exemptions, they can actually they have to apply with this in this format. And there is a format is given for European Declaration of Conformity format. So if any manufacturer want to place the triple E in European market, then they have to use this format for the declaration of conformity. So in RoHS Article 7, the manufacturer's obligations are mentioned. So other obligations are also mentioned in this RoHS directive, like importers obligations, suppliers obligations, like that are also mentioned. But I have taken only Article 7, which is applicable to manufacturer's obligation. So they have given that manufacturers has to draw technical documentation, carry out internal production controls, and provide declaration of compliance conformity statement along with the triple E means electric and electronic equipment, and they have to affix CE marking. So now if anybody is affixing this CE marking, that means the product will be considered as a RoHS compliant product. And RoHS 2 Article 18, so market surveillance requirements are also there. So earlier there was in RoHS 1 there was no such requirement, but in this article, in this RoHS 2 directive, it is especially mentioned. Requirement for CE marking and declaration of conformity effective from 2013. So additional record keeping requirements are also became mandatory to demonstrate the compliance. So during the service life of equipment, if they ask at like you have placed anything now, and if enforcement authorities are asking the document compliance documents after 10 years, then you must have those documents. So this is the requirement, mandatory requirement. And they actually come up with the assessment standard, that is EN 50581 2012 also, to fulfill the requirements of 768 2008 EC, so which are actually mentioned in this RoHS directive. So people actually this is one amendment directive has come for RoHS 2, that is known as 2015-863, but people in general are saying that it is RoHS 3, but it is just amendment of Annexure 2 of RoHS 2. So it actually this amendment has come up with 4 phthalates, addition of 4 phthalates which are mentioned DHP, DBP, DBP, DIBP. Max 0.1%. So now total list has become 10. So if anybody want to comply with the RoHS requirements, RoHS 2 requirement, then they have to comply with this amendment directive also. So they have to see the compliance and observe the limit which are mentioned for 10 elements over here. So what will be means requirements of compliant products? So they should comply with maximum concentration values per homogeneous material, which are actually for 10 elements, and do comply with the procedural requirements. Like they have to submit declaration of conformity statement, and they have to affix CE marking logo on their triple E or product. So these are the requirements, mandatory requirements. If anything is missing from it, so it will be considered as a non-compliant product. Like you are complying with the maximum concentration values per homogeneous material, but you are not submitting declaration of conformity along with the equipment, so it will be considered as a non-compliant product. If you are submitting DOC and you are not affixing CE marking logo on it, so it will be also considered as a non-compliant product. So basically, we always talk this maximum concentration limits of 10 elements in homogeneous material concept. In homogeneous material, so this is a homogeneous material concept actually defined under RoHS 2 only. So means any uniform composition throughout the material, or we can actually we can do some we can actually separate from different material by unscrewing, cutting, crushing, grinding, and abrasive process. So those components will be considered as a homogeneous uh, material. So these are the examples like plastics, metal, alloys, paper boards. These are examples of homogeneous material. So if you this is just for illustration. So if we have mixer grinder, we have to test for maximum concentration at our laboratory. So we will actually go for this process. So this was actually overview of RoHS 1 and RoHS 2 and its amendment. So now we'll discuss about this EU REACH regulation. So this is the agenda to discuss about this REACH regulation overview, purpose, scope, and what are the actually duties of communication or notification for the suppliers or manufacturer. So this REACH stands for R stands for registration, E means evaluation, A for authorization, and restriction of chemicals. So it came into effect on the 1st June 2007. So it replaces approx 40 pieces of legislation within European Union. So earlier there was a case if you want to export from within European Union from one country to other country, then they have to comply with the requirement of the country of destination and country of origin. So now after this REACH came into effect, so you have to comply with REACH requirement, and you can actually sell your products freely all over European Union. REACH actually places greater responsibility to industry to manage risk. Means if we are putting chemicals in the European market, then we are the responsible that it should be safe for environment and safe for human health. They created one agency that is known as European Chemical Agency. So purpose of the REACH regulations, like we have discussed about RoHS purpose. So it have some same purpose, but RoHS is a sectorial requirement, like it is only applicable to electrical electronic industry, but REACH is having a broad scope, and almost it is covered with everything which are not exempted in the scope of REACH. So to provide high level of protection of human health and environment for the use of chemicals, and the main purpose free movement of substances on their own preparation or articles in your market to enhance innovation and competitiveness of the chemical industry, and for the alternative methods for the assessment of hazardous properties. So So this is most important actually article of REACH. So we have taken it as it is from regulation, that is no data, no market. Means you have to, if you want to put any chemicals in the market, then you have to comply with the requirement mentioned in REACH regulations, and you have to provide each and every information related to your chemicals. So this is the definition. Means these are the main definitions of under REACH. They consider as substance, mixture of preparation, article. So substance means anything which is in pure form, and mixture consisting one or more substance, more than one substance, that will be considered as mixture. Article means object which during production given a special shape, surface, design, which have greater degree of uses than its chemical composition. So that will be considered as an article. So these are the examples for substance and preparation. So like if you want to there is a brass, then there will be usage of copper and zinc. So that will be known as brass. So brass is a mixture or preparation. Copper and zinc are substances. So scope of the regulation means REACH applies to the manufacturing, porting, placing on market, use of substance on their own, means in pure form, in preparation or mixture, or in article. So it is actually applies to all chemical substances, not only which are used in the industrial process, but in our day-to-day lives, like examples in cleaning products, paints, articles such as cloth, furniture, electrical appliances. So it is applicable everywhere. So things which are not exempted under REACH, so applicable under this. So this is the exemption under REACH. Radioactive substances actually governed by 9629 Euratom. So those are exempted. Anything for under custom supervision and for means transport purpose, which will not be placed in the European market. So those are exempted. Non-isolated intermediates. Anything which is actually transport by rail, road, inland waterways, or sea. So because they have a separate directives or regulations to govern those chemicals, that is why those are exempted. Waste, which is actually defined under Directive 2006-12 EC, so those are exempted. So these are the list. Means if any legislation have specific means more stringent than REACH, so those are also exempted, like human and veterinary medicines, food and foodstuffs, additives, and plant production products, biocides. Those are exempted under REACH.
Yeah, Amit, we are running short on time, so can you do it?
So knowledge means REACH registration. So you have to submit data, hazard data to the authorities. They will examine about it for registration. This is so any substance manufacturer, if placing any substance more than 1 ton per year in the European market, they have to register their substance. If they are placing more than 10 per ton per year, they have to submit CSR also. So who has to register means manufacturer and producers has to register. Importers can register, or only representative can be assigned. So evaluation means is just whatever the registration dossiers we submit, it is evaluated by the authorities. So this is known as evaluation. So authorization means it applies to SVSC, which are actually a category of CMR, PVT, VPVB, or substances of QRN concern. So those some of them are actually go for the further authorization. So people have to apply for the authorization. So restriction of chemicals. So basically, if it is more regulation is required for some chemicals, so those are actually listed under restrictions list, that is an Excel 17 list, which is applicable to all manufacturer and exporter. Means if those are not placed in the European market. So this is the actually article manufacturer under REACH. So to register if released from articles and they are placing that substance 1 ton per year, then they have to go for the registration process. Otherwise, they have to notify that substance if it is in candidate list, that is SPSC list, and they are placing more than 1 ton per year, and concentration is 0.1%, more than 1%. So this is, if these are the criteria are met, so they have to notify to ICA. And for communication, that is actually requirement of Article 33. It is applicable to article supplier. They have to communicate if anything is present more than 0.1%, and as SVSC. So these are the requirements are listed in a REACH as a article manufacturer. There are exemptions also if you are using that substance and that substance manufacturer has already registered for that uses, then you don't need to go for registration or don't go on process also if that particular substance is registered by substance manufacturer itself. So if you can avoid exposure, then it is also exempted. So, like normally, if we are out of European Union, then we have to search what are the SVSCs are actually listed by European Chemical Agency. You have to find out those are actually present in your article or not, more than 0.1%, and you are placing those things more than 1 ton per year or per year. Then you have to, on the basis of that, your obligation will start. Means like you have to notify it if it is more than 1 ton per year. If it is not, then you have to communicate to your supply chain only. So until now, there are 211 substances are actually listed as SVSC, and you have to perform the test, or you can get data from your supply chain if those are present in your product or not, and that testing can be done at TU India also. So thank you for your time.
Thank you. Thanks a lot, Amit. I'm audible.
Yeah, quite audible.
Yeah, okay. Thanks a lot, Amit. Wonderful presentation also. I think in terms of discussion, you have discussed regarding the REACH, the registration, evaluation, authorization, and restriction of the chemicals, regarding the exact chemicals which can be used, which cannot be used. I understand that it's important for both the manufacturers, the importers, as well as the customers. They have to be aware of the health and safety repercussions in case they are importing. And I think what you discussed was in terms of greater than 1 metric ton SVHC are something which is critical. Also, I think a wonderful insight in terms of RoHS. Most of our people are aware regarding RoHS, but I think today's session brings in a clarity regarding what exactly we require as far as restriction of hazardous substances is concerned. I think everyone was aware regarding basically lead, mercury, cadmium, and hexavalent chromium, which have been banned for quite some time. But I think the latest modifications and changes have included the polybrominated biphenyls, bis-2-ethyl hexyl phthalates, the butyl benzyl phthalates, dibutyl phthalates, so diisobutyl phthalates. So I think some of the phthalates which have been included recently, it becomes more and more critical. So both the things in terms of REACH and RoHS and how these compliances help in terms of health, in terms of long-term sustainability, in terms of both organizations growing and the safety of the consumers who are using the various articles which are molded out of those products. Thanks a lot, Amit.
Yeah, thank you.
We can you share your presentation or?
Yes, I think I can.
Yeah, I think that will be great because Alexi will be covering the environmental impact of halogen-free FR products, especially related to the STARFLAM and the FORMPOLY grades. So, Alexi, please, stage is all yours.
Can you see my screen already?
Yes, we can.
Can you see my screen?
Yes.
Okay. So I will be very short because we are running a bit of out of time. So I will simplify what I have to present. But I would like to pose a few ones to Amit too, because it was a very nice presentation and it opens question even for me. Okay. So let's go to this presentation. I think you can see. So no, we are now in a new company which is called Ascent Performance Material, and so we have to talk about safety. And I think this is the best case for me to talk about safety, because flame retardant in plastics is inherent safety, meaning that you are adding safety to your plastics, and it's so much important as a product. But meanwhile, flame retardant is not, I always repeat this, is not as simple as that. You know, people think, yes, I buy a material from you, I just need a color, I need an anti-static, I need a lubrication agent, and this is a simple one. When you are talking about flame retardancy, is so much different. It's not just a matter of a few you're really changing your formulation, you are changing your product. This chart explains really what it's about. If you flame retardant, you have to make compromises. The right one at the right cause, right application. But it's not universal. It depends also to the thickness of the part application. You know, we have some systems that works very fine for high thickness. You have system that works very fine, mainly at low thickness. So yeah, I move on. If it's not okay, just tell me. So just meaning that you have an influence of flame retardant on requirement, on appearance, and on other properties that are not the usual one, like impact, flex. It's also corrosion, what it's about, and stability, and you cannot process every material for every application. And when what you think it's only about fire, but fire is one part of the safety. A flame retardant is characterized also by smoke property, smoke density, smoke opacity, and corrosivity, because sometimes flame retardant can lead to chemical abrasion, let's say on screws and tooling, which is important. And of course, which is getting more and more important now, is the environmental impact. Why? Because flame retardant are sometimes chemicals. And when you are playing with a flame, you have to find a mechanism to stop the flame. And it's not made only by very simple things. You have to use real chemicals to fight the flame. So if we scroll rapidly what is it about, so it's mainly here for polyamide, because as Rashmi said, our company is really focused on polyamide, and we are quite strong in this business, whereas for some other, to have halogenated compounds, the ISO code for this one is 10 to 25. So halogenated is quite an old material, but still very effective. Nitrogen compounds, organic phosphorus compounds, inorganic compounds, metal oxides, boron, and others. And all those one has a different trace in terms of environments, in terms of impact, but impact not only in producing those flame retardant, but using those flame retardant. Some of them, for example, exhibit a hazard when in use, some other while they are produced, and some others while they are transformed. And all that has to be in line with requirements that are not only mechanical or regularity requirements, but also part requirements. And this is what we see here. When we are using a flame retardant formulation of product, you are facing a world of regulation. You have, of course, technical regulation. These are well known. These are the IEC standards, meaning the baseline to enter those markets. You have to comply with certain rules. But you have also environmental regulation. And this is what Amit says. It has really more and more important in the business. And if you don't comply with those regulations, you can simply not use the material. And you have eco-labels. Non-government organizations are now putting a lot of pressure on materials and on those labels. And let's say it, but then you need to comply with regulation what are moving. And something is what is true one day might not be true another day if we discover a product might be harmful. And above all, when you are located on the globe, depending on when you are located on the globe, then you have to comply with different certification. And all this make that it's very difficult, or you have to comply with so many things. Here in this chart, it's kind of polymer compatibility regarding flame retardant. So of course, when you are designing a flame retardant, it's an interaction with polymer. It's not just adding an additive in a formulation, but what works everywhere for every application in every conditions. It's always a matter of compromise, and of course, polymers are only fuel derivatives, meaning that basically it's crude oil that has been refined and transformed into a polymer. So basically, it burns. So you have to use different strategy to make it flame retardant. And we won't go into details from the chart, but you see that depending on the nature of a polymer, you have different ways to choose from flame retardant, and some of them are more or less, let's say, environmental friendly. In terms of performance, this is what I tried to explain previously. When you add, for example, a reinforcing agent, let's say you add glass fiber to a polymer, then you will have to look at all this kind of spider chart, you know, but here, with flame retardancy, you are in another dimension, because as I explained, flame retardant has an effect not only on electrical, but many other properties. For example, electrical might be a lot imparted by by flame retardant. Some flame retardant and cannot be processing in terms of temperature, because some of is carried in the polymer in the formulation by a carrier, and in some cases the carrier is, for example, polystyrene, and everybody has burned polystyrene, and you can find or measure these very dark fumes. So smoke is important. And corrosion, which is quite new. Why corrosion? Because some of them are based on phosphorus, and in some conditions can release, for example, phosphonic acid or other acid or bromiteric acid, and those acids are quite aggressive to tools, to molds. So this is another dimension that has been taken into account. Performance-wise, we say, of course, we have a lot of things that need to be checked, but most of the time it's a compromise between electrical, mechanical, and thermal properties. I will scroll very rapidly, yeah? And just to scroll rapidly above what we have as a range, one is FR30 in ISO designation, is melamine cyanurate. This is a very handy one, cost-effective, very efficient. Sorry, both page was halogenated. I went too far. So halogenated is an old product, very effective, very proven in capacity, but that can lead to some drawbacks in some cases. Limitation are colors, sometimes chemical wear of screws, and tends when burned to decrease acids, so they cannot be used, for example, in telecommunication systems. So FPL has a very nice range, with FORMPOLY range based on many compounds. I will not go into detail, but you have polypropylene, ABS, nylon 6 and 6,6, and this is a very versatile product system that can be used for unreinforced, for reinforced, and many reinforcement can be used. Non-halogenated compounds. So here we see the melamine cyanurate in this case. So as a takeover, we say a very cost-effective system, a very friendly system. Limitations is mainly the very i.e. its stability and the ability to make V0 with reinforced glass. But there too, it's a proven system, and we have a very nice range, the STARFLAM range and FORMPOLY range, that covers a huge amount of product, from unfilled to glass filled, from 6.6 and copolymers. I go very far because I would like to take time for questions. And current trends, of course, with what we see as a future for plastics or for flame retardant, is a growing influence of regulation and growing influence of eco concerns. So, of course, we are restrained from use of a lot of things that can work fine. And for example, nano flame retardants, what works fine, but are not perceived. You have TPP, RDP, phenyl phosphate, that are more and more considered as let's say, as a chemicals dangerous for the environments. Bioaccumulative products are not perceived well anymore. So really, this is something that we are having a lot of care within our company to propose on the market products that are safe, not only safe in use, but more and more safe in their recycling end of life purpose. So, of course, flame retardant can be found everywhere, and we have a nice range now for trains. So material can be used in trains, out of trains. And what's new in this regulation is we are not taking into account not only the flame retardant performance, but also the fume toxicity, the fume opacity, and everything that makes material safe in use and safe in recycling. So as a company, Ascend FPL has a very huge range. We have more than 120 yellow cards, and we have most of the material are RoHS and WEEE compliant. And we have, let's say, added features like laser marking, like easy processing. Maybe I have to almost to stop, so I will go very fast now. But one thing is even more important is now what we see is that more and more materials, more and more apparatus are considered as unattended appliance. And this makes a huge difference in terms of requirement and safety. Because if you are using a material that can be handheld, if you have a problem, you just switch off the switch, or you remove the plug and you are safe. But more and more apparatus are used unattended. And a thing is that we change our life is cars, electrical cars. They are used as an attended device when we are driving them, but if they are in the garage being recharged, then they become an unattended device. So I think I will not present this. It's just a matter of selection of material. So we can help you, and people from FPL can help you finding a good material for that. And of course, it's a matter of compromise, and it's a matter of material selection. So you have option, and we have option now to find material. Smoke density. This is more and more important because up to recent times, flame retardant behavior was only measured as a UL, more or less, test, and it was a pass or fail test. But some of material were really strong V0 material, but releasing a lot of fire and smokes, and it's no more considered safe now. So just this slide, just to show that now for trains, we are not considering not only flame retardant, but oxygen index, gas density, gas opacity, and gas toxicity. So with the range, we really have a huge range now. I think everything can be covered. There are not so many applications that we cannot cover with a joint range we have now with FPL and Ascend. So please, if you have a request, ask, and there should be a compromise somewhere. Action of flame retardant, I think it's really it's never one single way to flame retardant material. But it's always the same thing. You have to break the triangle of fire, meaning you have to act or in the gas phase or in the condensed phase, or you have to remove oxygen in the surrounding. And this is a chart I like the best. We are still processing all the type of flame retardant, but no one is perfect. No one is better than another. It's a matter of compromise. In cases we would advise red phosphorus, despite its drawbacks, brominated, because in some cases it's still the best, but we nonetheless are going into direction of eco flame retardant, and among that we have a range, and there too, depending on the application, depending on a criteria of acceptance, the best one for you might not be the best one for a customer having a very close application but a different market. So there too, we can help, but we need to know the requirements, and only the requirement can make you make a good choice. Okay. I've been very fast because I know we are already late as usual. But if you have questions, just please ask, and we will try to answer.
Yeah. Thank you, Alexi. Can you hear me? I'm on mute.
Yeah,
Very far, but now it's okay.
Yeah, okay. Thanks, Alexi. Thank you very much. Thank you for sharing the products, having a discussion on terms of the application.
Very nicely the RoHS2 and its evolution. And in this new version, there is the phthalate. And phthalate, of course, is something new for everybody. And for us, it's a bit complicated because when we are giving an RoHS compliance, most of the time is on, let's say, elements that we can measure with an X-ray gun, let's say, by X-rays. And phthalate needs other measurement method, and sometimes it's very tough to give compliance with phthalates. It's can you comment on that? Amit, let's say the introduction of phthalate that brings problems.
So basically, whatever the things we are doing with the XRF, extra fluorescence, so we are conducting a test for metals only: lead, cadmium, chromium, mercury, and bromine, not PBB and PBD. We are measuring with the XRF. So we are actually measuring PBB and PBD with GCMS in our laboratory, and phthalates also we are measuring with GCMS.
Yeah.
So that
it really adds complexity, yes, to this. A lot.
So I think
thank you.
There is another question. I think it's related to Alexi's question. Which test method is followed for identifying the presence of RoHS restricted elements?
Method are there.
IC 6. Could you just repeat
I think
the
6
number?
to 2, 3. I will get back to you with the exact number.
Okay.
But
okay.
it's IC 62301. I think. Yes.
Okay. Then I think there is one question, Satish. I think with green screening, putting FR30 MCFR system under benchmark 1 based on the hazard rating, are you working on any alternates or have any proposal for PS6 FR compound with similar performance and cost of FR30?
Unfortunately, no. We know this threat. We know we know this green screen scenario, and ratio performance for polyamide. So we have alternate solution. For example, magnesium hydroxide. This is the material I like the best as a flame retardant because it's an hydroxide. So when you hit this material, it cools down the flame, it releases water vapor, and it's a very, very safe material. but you need a lot. You need 50% in your formulation. So it cannot be a one-to-one replacement to FR30. So of course we are working on greener additives, but
Alexi, we can't hear you. Can you just repeat the last line?
it prevents also sometimes to add new chemicals in the business. So it prevents from using a new flame retardant. For example, you have new flame retardants, for example, for GWIT, but it's difficult to use them because they are not registered. And the registration costs a huge amount of money. As Amit says, when you are bringing something new to the market, no data, no market. So it's now more and more difficult to bring new flame retardant to the market. So it will take time. We will be there, but not yet.
Thanks, Alexi. You want to add something on this, Amit?
No, it's, I think, sufficient. I just wanted to confirm those numbers, IC 62321, part 5, part 7, and part 8 are used. Part 8 is used for phthalates.
Okay. Then there is one question asking about alternate solution for PVC material since it contains chlorine.
I think, to be honest, PVC is a good material. You have to use it. What is it good for? But it's an inherent flame retardant material, and sometimes we can replace PVC but other products. But PVC is a quite cheap material. It's an elegant way also to capture chlorine. So I think there is no good or bad material. We always say there is a good material for a good application, and replacing PVC, of course, is a goal, but sometimes it will work with other products that can be a polypropylene based or ABS based. But then it's true that you have to add a flame retardant to the resin, which is inherently burning, whereas PVC is a self-extinguishing material. So replacing PVC is nice in some cases, but in some other cases we would still advise to use PVC.
I think, Alexi, there is one more question which is directly to you. Do you have any proposal on achieving 5 dB rating with high impact strength greater than 30 kg per centimeter square? And I think the previous question he's asked is also similar. What will be the maximum impact strength we achieve in halogenated flame retardant compounds? Is there any limitation?
We are working on this one, and let's say 5, with, for example, STARFLAM P1002E, so a nylon 6 with melamine cyanurate, and we are now listing this product 5VA on freaking on new things. For example, we are working on maybe on a red phosphorus grade with improving. So yes, it's a trend. It's just not like adding a lubricant or a color in a formulation. Adding a flame retardant changes dramatically the structure of a flame retardant. We are not in the ppm range. We are in the tens of %, and for sure it has an influence on properties.
There is one more question, Alexi. This is regarding phosphine emission. Is the phosphine emission in both red phosphorus as well as organic phosphorus FR compounds, or is it only limited to red phosphorus compounds?
No, phosphine emission is limited to a red phosphorus compound, with an exception, which is a white phosphorus, but it is not so much in use in polyamide. But yes, it's linked to red phosphorus, and this is something that can be avoided easily. Because if you are processing a material that has been processed and produced carefully, like it is as it is produced in at FPL and Eurostar, meaning with a lot of care, if you are processing with material in dry conditions, you are not releasing phosphine. Phosphine is only released when the product is badly produced, and it's not the case in our company, we are putting a lot of effort to produce as clean as possible. And if you are processing dry compounds, phosphine is only a reaction with water. So if you are processing a good material in dry condition, you will not have phosphine in red phosphorus-based compounds. That's for sure.
I think we have a few more questions, but I think I'd request Mr. Shekhar in case he could give inputs, because he has been at the forefront as far as Formulated Polymers Limited is concerned, to drive the environmental and regulatory compliances within India, especially since it's a little bit difficult. I think I would request him to have a short discussion in terms of why this initiative and why Formulated Polymers has been in the forefront in driving and implementing these necessary regulations.
Yeah, nice, Rashmi. I think all said and done, I think we have to comply. I think India has been complying the carbon emission norms among all countries. We are the leaders. And so obviously on all these environmental issues, India is also really getting up. I think now we have got in plastic, so much of regulation has come in terms of disposal and recovery, which was not there a few years ago. Last 4 or 5 years, a lot of things have come in. Extended producer responsibility also has come into India. So even everybody is responsible for whatever plastic which is part of the packaging to be recovered. So I'm sure in engineering application also, all these compliances we have to meet, because more or less most of the Asian countries are just adopting whatever Europeans are creating as a legislation. So in the near future, we are going to happen. And also, of course, a lot of our products are end destination is Europe or US, because of the cost of production is much cheaper in Asia. People are getting produced here and shipped there. So obviously, we have to comply. Okay, so I think we have to comply for the better next generation. Okay, so all this for running for the fact, and we really want to be a leader in that, and in terms of compliance. Yeah, I think we can see the other questions which are there, Rashmi.
Yeah, thank you. Thank you. I think we're running short on time. I think the other questions which have been asked, we'll be replying them directly on one basis. So next series, so we will be having a discussion in July. Still scheduling the dates. I think Alexei, being an expert, will definitely be sharing his insights on cross-linked polymers. And I think most of the team members would be interested. There's a lot of interest generated by various. I think it's an area where we would have a good participation and interactive session. So finally, I'd like to thank everyone for joining. We appreciate your support and hope that you have gained from this webinar. In case there are any queries, you can directly get in touch with Alexei, Mr. Amit Bahadur Singh, or you can coordinate with us. We have shared our website, our email IDs, as well as mobile numbers. So I think I'd like to thank the presenters once again, both Alexei and Mr. Singh. Thank you very much, and a special thanks to IT department, Mr. Velumurugan, of R&D, Mr. Alvar, who has helped us to make this happen, and Mr. J. Sarvanan BD, who has been coordinating and working hard, along with all the regional business development managers who have been working substantially, coordinating and passing on the information across various networks, so that people can join us and have this session. We would also invite presenters for our next sessions. In case they are interested, please get in touch with us. This is a knowledge sharing platform, so as many people as are involved, it'll be good because we want to share the experiences, what we have gained over the last maybe 10, 15, 20 years or whatever, so that the next generation has an advantage and doesn't make the same mistakes which we have made. So at least we work together and we enjoy definitely as far as our experiences are concerned in this particular industry and with the applications. Thank you. Thank you very much.
Thank you, Rashmi. Thank you, Alexi. Thank you, Amit.
Thank you.
Thanks, everybody.
Bye.
Goodbye. Bye.
Bye bye. Thank you.
Thank you. Bye.